Let's begin the interaction lab by setting up the hardware. Take masking tape and label one of the sensors A and the other one B. Hook sensor A up to channel 1 and hook sensor B up to channel 2 of your interface. Connect the interface to your computer with a USB cable. Load Logger Pro. Logger Pro has detected that 4 sensors are hooked to it and is giving us readings. However, we're going to use a different program that Rex has created. So I'm going to open. We'll go to your Google Drive, Unit 4, Resources, in3 Labs, Interactions 1 through 8, open. And we can see that A has a reading in red, B has a reading in blue, and there's also a red and a blue arrow at the bottom. However, no force is being applied to the sensors, and yet we're getting readings, so we have to tell the software that this should be 0 force. So I'm going up to the 0 at the top, clicking on it, tell it OK, 0 both sensors. We now get readings very close to 0. If I take sensor A and pull on it, I'm getting an arrow to the right, and push on it, I'm getting an arrow to the left. I have sensor A on the left side of the 2 sensors. So that matches. B, I'm pulling to the left and getting an arrow to the left, pushing to the right and getting an arrow to the right. If I want to see this graphically, I'm going to 0 it again. Push collect, push on A, pull on A, push on B, pull on B. So I get animated arrows, and I get a trace for each sensor. So our hardware is set up and ready to go. Now let's go look at the lab. So let's go get the lab. You'll find it on your Google Drive. Unit 4, Resources, in3, and Unit 4 Lab. Open. The first page is a page of detailed instructions. The second one goes through each interaction that's going to happen in the lab. And we want to go to page 3 and start at station 1. 2 students pushing on each other. One student will be student A holding force sensor A, the other student B holding force sensor B. The reading on sensor A is the force that A is experiencing due to B. The reading on sensor B is the force that B is experiencing due to A. So we're going to make a diagram of the situation, a force diagram for each object, each student A and B, and that will be of the format shown here. Okay, this is the physical diagram. A is on the left, B is on the right, and they are pushing on each other. Force diagram should be of the form force on the by the. So here we have force normal on A by the floor, force gravity on A by the earth, force push on A by B, force of friction on A by F, the floor. Okay. Then we ask students to make a prediction. Is force A on B going to be greater than B on A? Is force B on A going to be greater than force A on B? Or are the two forces going to be equal? I believe that force B on A will be greater than force A on B. Since A is the only person pushing, the force on B from A is going to be greater. So now we're going to go take data. When taking data, you must keep in mind that the sensors can only take data in one dimension. The sensors must be pushed or pulled along an axis through the sensors. The stopper faces should be in complete contact, so there's no upward or downward push with the stopper. To facilitate good data, it's easiest if the sensors are placed on a countertop. In this trial, B will be held firmly in place while A will be pressed into B. I'll zero the sensors, push collect, and get data. So if you get close to 10 newtons, you need to back off. And now that you have the data, you go back to the lab sheet to record it. Once you're done with the data taking, you come back to the worksheet, the lab, and draw in a blue trace and a red trace for what the graph actually looked like, and write the result in on the line. Then you go on to number 2. Student B will push on student A while student A passively holds the force probe, make a prediction, go get the results, draw in the graph, and write the result. When you're done with that, you go on to station 2. Now rubber bands will be placed between the force sensors, and students will pull on each other instead of push. Then you go to station 7, where carts are going to collide on a track, equal mass carts, and then station 8, where they will collide, but one cart will have more mass than the other. Here's a quick run through of the trials where you have collisions. In number 7, you will have 2 equal mass carts. In one case, the moving cart will strike a stationary cart. In another case, you will have 2 masses striking each other at the same speed. And in the third case, you will have a slow-moving mass striking a faster mass. In number 8, you're going to add mass to one of the carts, and you will have the low mass cart striking a stationary high mass cart, a high mass cart striking a stationary low mass cart, and both carts colliding at the same speed.